Hi students, for the continuation of the learning with respect to the software visual components for the course Factory Simulation Laboratory. So let us get into the things what we covered so far. So as of now, we have covered 4 lectures where you got into the importance of the factory simulation activity. Then we got into the functions, the features of visual components using a PowerPoint presentation. Then followed by the same thing. The third lecture was with respect to the demonstration of the visual components software. And the next was where you got to know about the working of visual components for exercise number 1, that is modeling and simulation for workstations involving human interface. So now in the series of lecture, the next lecture we are going to learn about exercise number 2. The title is Modeling and Simulation of Workstations with Robot Interface. So the preamble is very simple. It is the same, similar nature to exercise 1. Perhaps the significant difference here is instead of human, we are going to have a robot. So that's all is going to be the difference. So let us get into the objective. So the objective of exercise number 2 is we need to simulate a manufacturing workstation where robot is going to interact with the machine and it is going to assist us in material flow. Of course, we are going to do by means of visual components. So that is what exercise 2 is going to deal. Now let us get into the understanding of this thoroughly so that it helps us to pick and place the necessary components in order to complete exercise 2. So the block diagram as usual, we have got a conveyor number 1. Of course, with a predetermined distance, we have got conveyor number 2. So we are going to have 2 points. The first on the conveyor one, it is going to be a source, and a point on the conveyor number 2 is going to be called as destination, and an industrial robotic arm is going to be placed in between. Of course, whenever we go for any such resources, it has to be controlled. Therefore, we need a controller. We need to interface them. And of course, on the other end, a machine is going to be there. So here, with respect to exercise number 1, we have got two significant difference. Difference number 1 is going to be human is going to be replaced by an industrial robot arm, number 1. And number 2 is we are going to have a machine tool. So the machine tool, what we use here is a CNC lathe, a CNC turning machine by the name FTZ350. FTZ350 is the machine what we are going to use. So as usual, the output of the exercise will be number 1, where we are going to get the video recording as usual what we did in exercise number 1, followed by we are going to get the PDF drawings, and the third is going to be the bill of materials. So now we will get into the exercise directly. So we launch visual components and we get the trolley number 1 and we position it. So we need to have the keen observation with respect to the flow direction, in which direction the component is going to flow. Now we will go to model by manufacturers under visual components. We will go for the PM flow components within which we will go ahead with feeder. So in the previous exercise, as a beginner, we searched everything. We went to the search tab and we searched. So upon experience, we are supposed to be in a position to pick and place them from their locations. So now we brought the feeder, we positioned it. Then we brought the from process conveyor and we move it to the source point of conveyor number 1. So the moment the task is over, let us clone it and we get a copy of the conveyor number 1. Simply you can even go ahead by Control C plus Control V. Even the same can be done. Then from process was deleted and to conveyor process is now brought in, and let us position it to the necessary point. So now it has been brought to it. Now deliberately I'm taking to one particular end, but still it is possible. Again, we can adjust it even after providing a link. In order to demonstrate it, I'm just taking it to you guys. So you don't have a conception that only in that particular position. Anywhere on the trolley, anywhere on the conveyor, it is accepted. So now we'll get into the machine part. So let me go and search as FTZ and double click onto the FTZ 350. So let me position it on the top view so that the work volume is very near to the conveys what we have pre-positioned already, so that the robot arm will be able to carry out this task within the work envelope. So now we just positioned it properly, and now again let us come back to visual components, then we'll take the other necessary thing. So now the necessary thing is robotic interface. So under robot we'll get the generic articulated robot, but let us not position it, because the saying is like this: whenever we go for any resources, we are supposed to come with the controller. Unlike the earlier case where we just had a human transport controller, what we used in the previous exercise, it is not so. Because earlier case, what happened is anywhere on the configured part on the configured layout, you can just have the human transport controller. But robotic controller, it is not so. You need to position the controller properly, and you need to keep it in the proper position, because it is going to act as a platform, and above the platform, that is above the controller only, we are supposed to position the robot. So don't have a misconception. So what I wish to say here is the differences between first exercise versus second exercise in terms of controller is: number one, where in the previous exercise controller can be kept anywhere on the configured shop floor and you just go ahead with the interface. But in the second exercise it is not so. The controller itself will act as a platform. That itself will act as a platform, and above it only the robot has to be positioned. Now first let us position the controller. Now approximately we position somewhere equidistant to all the three elements, that is machine, conveyor 1 and conveyor 2. And now upon positioning successfully, let us bring it the robot on to the top, and as usual you will have the green arrow head, so automatically it gets into PNP, that is plug and play. Now, the other important thing is the robot is there. How will it be able to pick and place the component? It need to have a EOAT, end of arm tooling. Some sort of end effector is necessary. So here in this case, we will go for a 3-jaw generic gripper. So again, robot tools under visual components. The first component is a 3-jaw generic gripper. Now the same case, bring it to the end of the robot, automatically it gets positioned. Now we'll simulate whatever we did. Now upon simulation we realize that the part is coming, it comes to trolley 1 based on the predetermined interval speed, it comes to the feed process and it gets stopped. Because further path is not defined, henceforth that consider that as the destination and it just idles there. So now we'll go for the further establishment. That is, we'll go to the menu tab, within which we'll select the processes. So when we select the processes, we can see there are 3 labels are there, and when we go ahead with the flow, we can see the flow group 1 is empty. So this is the activity what we are going to do. So let me give a clear picture in this. There are 3 crucial activities are there. Activity number 1 is product. Yes, we brought the products. Activity number 2 is processes. There are 3 processes. They remain as independent entities. We need to provide a link, and that link is called as flow process editor. So that's what we are going to do right now. So let me click onto the label number 1. Then who is going to take care? The robot. Earlier case it was a human, now robot is going to act as an interface. So come hover around the controller where you will get the emblem of the controller, select it, then go to the label of the machine. Now the link is established. You can see in 2 ways. The link is represented on the configured model as well as in the bottom output editor, where even flow group 1 is having the conveyor number 1. In between there is an interpolation by robot, the logo is there, and it is followed by the machine. Now this is one half. The other half is the same from the machine. It has to come to the end thing. So deliberately that has been kept in the end. So now we can establish, and despite of establishment, we can move it at any point of time. So now we'll see. Let me move it up. Now, see, the thing is, we have established the link, then we are moving. Still, the process will work. So don't have a misconception that that is position oriented. So now the process is clear. We have speed up the simulation. So now the components come, it is loaded. We can change the view by using a right click. Now let me increase the interval. Earlier it is 5 seconds. Now let me change it to some 30. Now we'll see the simulation. The component comes on conveyor 1. It is loaded by the robot arm. The part is getting machined. Now it is positioned to the conveyor 2. So this is what a classical example of modeling and simulation of workstation involving robot interface. Now the next part, we need to go ahead with the drawing. So what we'll do is, first we'll go to the drawing, import the template A3, and then we'll import. So now we get the template. See, what is the purpose of this template is, see, without having a template, it becomes an infinite surface. It becomes an infinite surface where we will not be knowing what scale factor to adopt for the model. So therefore, it is going to act as a reference indeed. That's the purpose of template from a academia point of view. From an industrial point of view, of course, we have to go ahead with the shop floor space design. So therefore, the application is going to judge the way how it is going to be used. But from an academia point of view, it is having a constraint, therefore we go for the template. So let me rechange the name as factory simulation, the way how we did in earlier class. Then part number, let me go ahead with 212722, some sample number, a dummy number indeed. So after doing all these things, what the view we wanted to have, let us select the view. The moment we click it, the model is going to be brought up onto the drawing. Now we can go for the scaling. Now this template is going to give us the space limitation what we can have. So now two views I brought, they are getting merged up, so just delete them. So green is going to be indication of selection, let us delete. Now any one view we can have. Now what to do when you want to have multiple views means you need to go for multiple sheets. That's the only way. Now let me change the scale of the drawing. Yes, I think this seems to be a little bit modification is necessary. So it is purely based on the situation we can decide how you wanted to have. So when you want to pull means pull onto the arrow. Directly you can select the model onto the center. There is a jog, using the jog respective axis. Only we have got two axes, X and Y. We can position them and we can go ahead. Now bill of materials. On the top tab, there is a BOM create. So we did. Now we'll go for the PDF conversion. So the moment when you come, you can see nothing is there on the blank. So select the full preview. Now we get, now go for Microsoft PDF converter. Change the sheet size to A4 and go for export. Specify the path where the file has to be saved. Give a file name. After specifying the path, save it. So now thing is done. This is the model. Now we'll save the file. Again the same procedure what we learned in the earlier case. Specify the path in our respective folder. Let us save it onto the requisite name. Now the file is saved. So now we'll have the preview over the PDF model. What we did, let me go to my computer, browse the location and SFL exercise 2. So this is it. So finally we just got the model and this is the model what we have obtained out of the package. Let me summarize the activities what we did in visual components. We learnt about exercise 2, where the first exercise was with respect to human interface, whereas the second exercise was with respect to robot interface, where we added two new elements. The first element was a CNC lathe, a CNC turning machine, followed by a generic articulated robot. So the moment when we brought the resource by name a robot, obviously a robot transport controller was involved. In the earlier exercise, we had human transport controller, and now we have got a robot transport controller. And of course, an end of arm tooling, EOAT, in other terms, it is called as end effector. A three-jar generic gripper was used in order to hold the component. Then we, after going ahead with the editing of the product, we just went for the layout. We defined the layout within which the output was a flow, that is independent entities were made into a flow like chain, and we completed the loop, and within which we completed the model. And finally, we just went for a drawing. We saved everything to the requisite scale to an A3 template, and finally it was saved into a PDF in A4 sheet size. So with this, we come to the end of exercise 2. Thank you all.